Hello everyone, welcome to this video where we are given that the following diagram shows a pattern formed using matchsticks, and there is a very important statement here. Let Tn be the number of matchsticks in figure n. Yeah, so that means I'm going to highlight the n and the n. So what does T3 means now? So using the same phrasing for part A is pretty straightforward. If Tn is the number of matchsticks in figure n, so T3 will be the number of matchsticks in figure, yes, 3. Brilliant. Alright, so just need to use back the same phrasing and we are done with part A. Now for part B, we will need to complete this particular table. And for this table, let's see. Yes, you just need to look at the pattern formed by the matchsticks. Yeah. So for the first figure 1, the total number of matchsticks would be 1, 2, 3. Then if you look at figure 2, how many matchsticks did we add? Yep. We actually add 1, 2, 3, 4. And as we continue to figure 3, do you realize what every time what did we did? Yes, we always add 4 matchsticks to the previous figure. So in this case here, if we were to continue the pattern, then we would then have the following answer: 3 plus 4 plus 4. So we continue to add 4 to the previous figure. Okay, and that should do the trick. And therefore, for part C, what would then be the general term Tn of this whole number sequence? So for part C, I'm going to write it here. So for part C, right, I am going to make use of this formula for common difference. This is a common difference sequence because we keep on adding by the same number. Yeah, and therefore Tn is actually equals to T0. That means the term before term 1 plus the common difference n. Oops, sorry. So T0 means that previously is T1 here. So this T0, if you look up here, plus 4 will give me 3 matchsticks. So what number plus 4 gives you 3 matchsticks? Yes, -1. Yep. And therefore, I would be able to get -1 here. And I'm going to add, in this case, the common difference. I hope you can see that the common difference is 4, because we keep on adding by the same number 4, n. And that's the answer. Alright, -1 plus 4n, or you can simply write it as 4n minus 1. Both works as well. Let's move on to part D, where we will then need to find the number of matchsticks for figure 18. So now from here I will then be able to know that n equals to 18, and because we have successfully found the general term from part C, for part D, right, I'm going to just apply the formula or the general term. T18 is therefore equals to -1 plus 4n, and n is 18. And this will then give me a value of 71. And for part E, now for part E, they would tell us that n, the number of matchsticks is 103. Find the n. And again, for part E, we could simply make use of the general term. Tn is equals to -1 plus 4n, and in this case they tell me this number would be 103, and my job now, or our job now, is then to solve for n. Okay, so I'm going to add 1 on both sides, so that I will have 104 equals to 4n. Do take note, this will be equals to 0. 1 minus 1 is 0. And after which I'm going to divide by 4 on both sides. And therefore, final answer, I will get 26. So which figure has 103 matchsticks? Figure 26. Alright, with that we have come to the end of this particular question. So if you like this video, do give it a thumbs up. Thank you for watching and stay tuned. Hello everyone, welcome to this video where we are given a sequence of figures that is formed using dots. And Tn is the number of dots in figure n. So let's start to fill the table that is given, where for figure 1, T1, I'm going to just fill out the table inside, alright? So T1 here, just need to count the number of dots. It will be 1. Okay. T2, though, I saw 1, 2, 3, 4, 5. That means it's 1 plus 4, 5. Okay. There's a reason for me doing that, okay? And after that, I realized that, you see, after the 1 dot, I add 4, right? Then for the next pattern, I continue to add. Yes, continue to add 4. So in this case, this is 9. That means from figure 1 to figure 2, we add 4. From figure 2 to figure 3, we also add 4. And this has implications on the next part of this particular question, which is what then is the general term of this Tn here. Okay, and for part B, then we can see that it is actually a sequence with a common difference 4. The difference between the any particular figure and its previous or the next figure is always 4, and so we could then tap on this formula, and we will have T0 plus the common difference D times n. N, what is this T0? T0 is simply the number before figure 1, which is here. And if I were to add 4, then I will get 1. So what number plus 4 gives you 1? Brilliant. 1 minus 4, -3. Negative 3 plus 4 will give you 1. And so for this particular part, I will have negative 3 plus, and by now you should see that the common difference is, yep, 4n. So it's negative 3 plus 4n, or 4n minus 3. And we are done with part B. And for part C, how many dots then are there in figure 66? This simply means that n is 66 now. So since I already have the general term, all we have to do is to substitute this general term, the n, with 66. And with that, all you have to do is to just use your calculator. You should get 261. And for the last question, which figure has 201 dots? Oh, this is important. They're actually telling us the number of dots, meaning this is our Tn, and we are supposed to find n. Okay, and therefore I am going to substitute into the general term. The Tn now is 201 is equals to negative 3 plus 4n. And just solve for n. So in this case here, I just need to plus 3 on both sides, so that I will get 204 is equals to 4n. 3 minus 3 will be equals to 0. That's the reason why I decided to add 3 on both sides of this equation. And I'm going to divide by 4 on both sides, so that I will get final answer 51 is equals to n. Alright, so the answer, figure 51 will have 201 dots. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching, and let's move on to solve more mathematics question. Alright, we are given a diagram for this question with a sequence of figures formed by dots, where they actually tell us the figure 1, figure 2, and figure 3. What do we need to do? We need to use notations to denote the position of the figure and the number of dots, corresponding number of dots in that figure. So what exactly is this question trying to ask us? Okay, so basically this question, right, is trying to get us to write down this. So we are supposed to, in this case here then, let Tn be the number of dots in figure n. Done. Thereafter, we do need to give an example, yeah? So for the example then, for instance, for example, maybe T3 will then represent the number of dots in figure 3. And for part B, all we have to do is to find the number of dots in 7 and 10 respectively. I hope you can see what is the pattern. So that all we have to do for part B is that we are given the first 3 figure already, right? So this is what Mr. Tan will do. For figure 1, we have 1. For figure 2, we have 3. For figure 3, we have 1, 2, 3, 4, 5, 6. I hope you can see the pattern. This is we plus 2, we plus 3. So what do you think is the next pattern, next number? Yes, plus 4 to give us 10, and we shall continue until we reach the figure 7. So I will have to plus 5 now to reach 15, plus 6 to reach figure number 6, and continue the next line. Okay, so the next line would then be plus 7. 21 plus 7 will be 28, and that will be one of the answer because this is the 7th figure. Plus 8 to give me 36, plus 9 to give me 45, and the last one, 7, 8, 9, 10, plus 10 to give me 55. And so the answer for this would be 28 and 55. Okay, and so we have come to the end of this problem solving. So stay tuned for more mathematics questions in this channel. Hello everyone, welcome to this problem where we are given that a ball is dropped onto the floor from a height of 320 cm as shown in the diagram, and each time it falls, it rebounds. Oh, this is a very important piece of information. 3/4 of the height from where it fell. That means 3/4 of the previous height. And AN will be the height from the nth rebound. So for part A, right, we just need to follow this particular rule then. So A1 will then be 3/4 of the previous height, which will be 320, and that will give me 240 cm. And A2 will be 3/4 of A1, which is 240. That will give me 180 cm. A3 will be 3/4 of 180, 135 cm. And determine the values of A power A6. So we will have to repeat this for another 3 more times. And so we would then have A4 is 3/4 of 135, 101 and 0.25. A5 will be equals to 3/4 of this, and finally A6. Okay. Part C. Find the smallest value of n for which AN is less than or equals less than 50 cm. So if we continue, right, do take note that A7. The moment we reach A7, right? We would go below 50 cm, as this will be 42 point, this is 25 sig fig, sorry, 6 sig fig, followed by 3 sig fig answer. And the moment we reach this, we would have reached this stage where the height is less than 50, and they want the smallest. That means we don't go smaller and smaller anymore already. Yep. So from here we could actually then see that the smallest n is equal to 7. We have come to the end of this particular question. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.